Welcome everybody. Today we're going to be talking about matter and specifically how to classify matter. Now this is very important because different types of matter actually behaves differently, and it's important to know what we're actually working with. I want everybody to look at these two pictures here. We have water, which is H2O, and we have muddy water. Now obviously these two things are very different, but I want you to think about how are they actually different? What's the same about them, and what is different about them? First, we're going to talk about pure substances. Now, pure substances is like water. There is only one type of thing in water, and that is water, H2O. There's not multiple things involved. Now, we have two types of pure substances here. We have water and we have gold. Now, before going on to the next slide, please ask yourself, what is different about these things? How are they different and how are they similar? The first type of pure substance we are going to talk about is called an element. Now, we've seen these on the periodic table of elements, and elements are only made up of one type of atom. Now, this is different than the water that we talked about earlier because it's H2O. There's two hydrogens and one oxygen. So those are two different types of atom, whereas gold only contains gold. The next type of pure substance we are going to talk about is a compound. Now this is what I was talking about earlier with water. That is H2O, or two hydrogens and one oxygen. That means there are two different types of atoms in this piece of matter. A compound always will contain two or more different types of atoms, whereas the element only contains one type of atom. Now, what we've been talking about so far are pure substances. Now we're going to be talking about mixtures. This is where the muddy water comes in, because the mud or the dirt inside of the water is not combined to the water. It's still H2O and then other stuff in there as well. So as long as there's two or more types of matter in a sample, this is called a mixture. So now we're going to be talking about different types of mixtures. Here we have an example of chicken soup and Coca-Cola. Now before going on to the next slide, really think about how are these two mixtures different? The first type of mixture that we're going to be dealing with is the chicken soup. Now this is called heterogeneous. Hetero meaning multiple. Now what this means is depending on where you look in the chicken soup, it's going to be different. Sometimes you'll find more noodles, or sometimes you'll find more chicken, or maybe you just pushed all the carrots off to the side and now there's a bunch of carrots in this area. That is what heterogeneous means. It's not the same throughout. Now, what is different here with the Coca-Cola? As you may have guessed, the Coca-Cola is the same throughout. That is called homogeneous, which means one. So, depending on where you are in the Coca-Cola, it's not going to change. You're not going to take a sip in one area and get more sugar, and then a sip in another area and then get more bubbles, and then a sip in another area and get more, I don't know, acid. It's going to be the same throughout. No matter where you look in the Coca-Cola, it's going to be the same as another part of the Coca-Cola. That's called homogeneous. On this slide, we have an absolutely fantastic flowchart. Now, if you're taking any types of notes or taking screenshots or saving any part of this presentation, this is the part to save because this will help you out on any test, any worksheet, or any papers that you have to write on this subject. Now, let's start off with matter. That is what we are talking about today. The first question that we have to ask ourselves is, can it be physically separated? Now, this might be a difficult question to answer, but we have to think any physical process, can we separate the different components? For instance, putting it through a filter or a strainer, or maybe even just picking out the different pieces. That would be a physical process. Now, water, on the other hand, cannot be physically separated. We cannot separate the hydrogen or the oxygen through a physical process. We would need a chemical process for that. So that would be a no. Let's go down that pure substance side here. Once we know that we have a pure substance, we have to ask ourselves the next question. Can it be chemically decomposed? Now, I don't really like this question. I like to think about, does it have two different types of atoms in the substance? For instance, H2O, like we just talked about, has hydrogen and oxygen in it, so that would be a compound. Now, if it doesn't have more than one type of atom in it, then it is an element. You should be able to find that on the periodic table of elements. Now, I will say, any of these compound element questions, we will always give you some kind of chemical formula for you to look at. You will never have to guess on this type of question. Now, let's bring it back up to the top. Can it be physically separated? Now, if the answer is yes, then you have a mixture. Now you say, but wait, I can't physically separate Coca-Cola. But if you shake it up and then open the bottle, what happens? Well, you hear the tss. That is matter escaping. It is physically separating from each other. So that would still be considered a mixture. Now, once we know that we have a mixture, we want to go down to, is the composition uniform? This has to do with the chicken soup example. If we look at one part and it's the same as every single other part, that is uniform. It is the same throughout. If it is not, then it is heterogeneous. So homogeneous is the same throughout. That would be the yes side of things. Now, if the answer is no, and we have a heterogeneous mixture, there are two types of heterogeneous mixtures that we have not talked about yet. And we're not going to talk about them right now. We will talk about them later on in the PowerPoint, but just they are called colloids and suspensions. Now, going back to the top, the can it be physically separated portion of this. If you ever look at a label in a store, if it has a list of ingredients, those all can be physically separated. Those are different types of matter that are in this substance. But if you look at something like a water bottle, you will never find a list of ingredients because it is just water. Let's talk about some examples. Let's use our flowchart that we just wrote down from the previous slide, and that should help us out on these examples. The first one we're going to be talking about is graphite. Now, what is graphite? That is the stuff that we can find in our mechanical pencils. I know that we call it lead, but it's actually not lead. It's carbon formed in a very specific way. We have to ask ourselves, is this a pure substance? Well, it's only one thing, so yes, it would be a pure substance. And beyond that, it only contains one type of atom, carbon. Therefore, it is an element. Now the next part here is pepper. This is a little different. Pepper is a mixture of many different things that gives us the spice that we love so much. And especially when we crush it up, there may be bigger parts in one places and smaller parts somewhere else. It is not uniform. When it's not uniform, it is called a heterogeneous mixture. Sugar, you might think is the same thing, but this is called sucrose. Sucrose is a long chain of chemical elements that are formed together to give us the sweet flavor that we love even more than pepper. Sucrose, being that they're chemically bonded, would be considered a pure substance because we cannot separate them with a physical process. We would have to use a chemical process for that. Therefore, it is a compound. It's not an element because there are actually 3 different types of elements within this compound. Next part is going to be paint. This one might surprise you more than the rest. Now, paint is a mixture of many different types of chemicals along with water that gives us the colors that we paint on our wall. And you might think, why does this say heterogeneous mixture? Isn't it the same throughout no matter where we look? If you've ever bought paint, they give you a wooden mixture stick. What that does is it mixes the paint. Why do we have to mix the paint? Because if we let it sit, the paint or the colors separate from the water. Therefore, we would call this a heterogeneous mixture. If we leave anything to sit, it should not separate out. If it ever does, this is heterogeneous. Now, soda, on the other hand, no matter how long we leave it somewhere, it's not going to separate the sugar and the Coca-Cola. It's going to be the same throughout at all times. So this soda would be a solution. Now, solution, if we look back at our chart, it said homogeneous mixture is also called a solution. So that is also a correct answer to this, homogeneous mixture or solution. We're going to talk a little bit more about elements here. Now, elements are composed of identical atoms. So if we have a roll of copper, it's all of the same atoms there. If we have a sheet of aluminum foil, it's going to be all of the same types of atoms. Aluminum and copper we can find on our periodic table of elements. If we look up our periodic table of elements, you'll see all the different types of elements that there are in the world. If you ever are wondering, is this a pure substance or not, look on the periodic table to see if it's there and if your substance only contains one of those things. Now we're going to be talking about compounds again. Compounds are different types of atoms that are bonded together in a very specific way in a fixed ratio. That means that in water, for instance, you have H2O, 2 hydrogens and 1 oxygen. You're never going to get H3O or H2O2 because those would be different types of compounds, different types of substances. Now it's important to note here that the properties differ from the individual elements by a great deal. For instance, table salt is NaCl, sodium chloride. Sodium and chlorine come together to make table salt. Now, if you were to separate those two things, chlorine, we could not breathe in chlorine. It is very toxic to us. So we would die if we were to breathe in chlorine gas. Whereas sodium, if we were to eat sodium by itself, we would blow up. It would literally catch on fire inside of our mouths. So separately, these two things are actually very deadly, but together we love it in our food. Let's talk about mixtures. Now, mixtures are when we have two or more pure substances that are combined together. They're not chemically bonding together. You don't get a new string of a chemical formula. You just get those things mixed together. For instance, granite. We've seen granite in a lot of buildings and a lot of architecture. This is called a heterogeneous mixture. If we look at one part of the granite, it might be different from the other part of the granite. And we can see that there's many different types of rocks that are in this granite stone. Apple juice, on the other hand, is homogeneous. Now, homogeneous means that it is the same throughout. The apple juice will be the same no matter where we drink it. Now, where this differs from the compounds that we were talking about before, the sugar and the water in this mixture does not combine together to make different properties. If we drink it, the water in the apple juice will still affect our bodies like water, and the sugar in this apple juice will still affect our bodies like sugar. It is not any different than if we were to take those things separately. Now you may be wondering, how can we differentiate between homogeneous mixtures and heterogeneous mixtures? Well, homogeneous mixtures or solutions have very, very, very small particles. It's going to be the same throughout. If we could ever see the particles in something, then it's probably going to be heterogeneous. Now, if you have two different liquids and they look about the same, you might think, they are both homogeneous. The Tyndall effect can show us otherwise. What is the Tyndall effect? If we take a light and shine it through a thing of liquid, we might see the light going through the actual water. We can see it go through. If we look at that little picture there on the right thing, we can see the light going through the bottle, but on the other one, we cannot. So That is called the Tyndall effect. If we're able to see the Tyndall effect, that means we can see the particles, which means that this is not homogeneous. It is a heterogeneous mixture. So if we ever take a light, shine it through something, and we cannot see the light scattering back at us, then this is a homogeneous mixture or a solution. Alright, so like I promised you, we are going to get into colloids and suspensions. First, we're going to be talking about a colloid. What is a colloid? And I will apologize, this is where it gets a little bit complicated, but not too complicated. There is a very simple way to identify a colloid and a suspension. Colloids, if you leave them there, will never settle. But you will still get that same Tyndall effect that we were talking about earlier. If you shine a light through them, you should be able to see the particles and the light going through the particles. But if it's a colloid, they will never settle to the bottom. As you may have guessed, suspensions are the opposite of that. If we leave a suspension in an area, then it will separate. For instance, if we've ever had lemonade, left it out, and then we look at it and we have to mix it up before we pour it into our glass. Or even the paint that we were talking about earlier. That is also a suspension because if you leave it there, the water will separate from the paint and we have to mix it up. Italian dressing is a great example of that because the first thing we always have to do whenever we use Italian dressing is shake it up because it has separated. So that is what a suspension is. If the things separate when you leave them there, it is called a suspension. For our last slide today, we're going to be talking about examples of these mixtures. Now, we're going to be asking, are these colloids, suspensions, or solutions? Solutions were our homogeneous mixtures. Now, I want to reiterate this because homogeneous mixtures are not separated into the colloid suspension category. They are just solutions. Mayonnaise is our first example here. This is a colloid. There's a bunch of different stuff inside of mayonnaise, and you actually get different sections looking a little different. So this is going to be a heterogeneous mixture. We can see the particles in it, but if we leave it there, it will never fall out. It's called a colloid. Muddy water, on the other hand, is a very obvious one because if we have muddy water and we leave it there, eventually the mud or the dirt will sink to the bottom and the water will be on the top. So this is very obviously a suspension. Fog is actually a colloid. How do we know that? Well, we can see the particles. If anybody has ever been in fog and they see a car driving by with their headlights on, you can see the Tyndall effect right in front of you. So it is a heterogeneous mixture, but it is a colloid because it's never going to separate out or anything of the like. Salt water. What is salt water? Well, salt water is actually a solution. It doesn't separate. Once you mix it in, it's going to be mixed in, and the salt water, no matter where you take it, is going to be the exact same. And we can test this out if it has the Tyndall effect. If you mix up some salt water and shine a light through it, you're not going to see any type of Tyndall effect. Italian dressing we've already talked about. Italian dressing is just like the muddy water. Very simple to think about. It has to be mixed up before you use it. That separates so quickly. One person can't use it and then the next person right afterwards. You have to shake it up immediately before putting it on your salad.